Okay, in this class I just want to look at a little bit of information, or a little bit of revision work really on frequency distribution tables. So frequency distribution table is just a way of displaying kind of descriptive statistics. So what we do when we're collecting data is we collect something called raw data. We ask questions and we collect data and then we display it in some kind of way and organize it. And one of these ways of organizing and displaying data is through something called a frequency distribution table, or just a frequency table or a frequency distribution. So here's a question. It says, below is a data set showing the daily demand for iPads in a computer store over the last 20 days. So the question I asked is, I walked into the manager of the store and I said, how many iPads did you sell each day over the last 20 days? And he said, well, on this day I sold 2, and then I sold 1, and then that day I sold 0, and then 2, and then 1, and then that day I sold 3, etc. And I want to develop a frequency table for the data. Okay, so what we have here with any frequency table is we have something called the random variable, and then we have the frequency. Okay, the random variable is just, in this case, it would be the number of iPads. Okay, and the frequency is how many times each of those values occur for that particular random variable. So you can see here the number of iPads. On some days there was 0 iPads sold, on other days there was 1, on other days there was 2, some days there was 3, and on some days there was 4. Okay, and it's over 20 days. So one thing I might do at the end, I'm going to put in this sign here. This just means the total sum of, all the frequencies should add up to 20 if I have this correct, because there's 20 different days, and we're going to count up all the things. So if we look at the zeros, 0 in there, there, so there's 4 zeros in here. So in 4 days there were 0 iPads sold in this store. If we look at the ones, there is 1, 2. On 2 days there was 1 iPad sold. Look at the 2s, there's 1, 2, 3, 4, 5, 6, 7. On 7 days there were 2 iPods sold, iPads, 3s, 1, 2, 3, 4. On 4 days there were 3 iPads sold in the store. And then looking at the 4s, 1, 2, 3, 3 4s, and if I add them, 4 and 2 is 6, 6 and 7 is 13, 13 and 4 is 17, 17 and 3 is 20. Okay, so that's a data set showing, that's a frequency distribution showing the daily demand for iPads in a computer store. So the random variable here, x in this case, represents the number of iPads stolen, and f represents the number of days in which this occurs. The frequencies, the number of times that each of these data values comes up in this list. I want to find the modal value. Remember we said before that the mode is the most frequently occurring one, the one with the highest frequency here. The modal value is, sorry, not 7, classic error. The highest frequency is 7, that is for the value 2. So the modal value is 2. It has a frequency of 7. That means 2 occurs 7 times in my big list. Okay, find the median value. Well, there are an even number of values. What I've got to remember when I'm looking at a frequency table, I've got to remember that, let me just fix that. I've got to remember that this is just a big list. This is actually a big list that would have 20 things in it. The first 4 of them would be zeros, then it'd be 2 1s, then 7 2s, and then 4 3s, and then 3 4s, if I was to write that list out. So the median value in a list of 20, well, it's an even number in the list, so there won't be a middle 1, but there will be a middle 2. The 10th and the 11th. There'll be 9 entries before the 10th, 11 entries before, or 9 entries after the 11th. The first 4 entries are all zeros, the next 2 entries are 1, and the next 7 entries are all 2s. So the first 4 entries are all zeros in my list. Entries 5 and 6 will be both 1s, and then the next 7 are all 2s. So that means that entry number 10 and entry 11 both have to be 2. So the median is going to be one of those 2's. And then find the mean value. To find the mean value, I have to add up all the stuff and divide by the total number of things. So I'm going to be a little bit careful here to find the mean. When I look at my table, again, you've got to remember your table is a big list with 4 zeros in it. So if I add up all the items in my list, all my data points, there's not just 1 0 in here, there are 4 zeros that I would have to add up. And then there would be 2 1s in the list, and then I'd have 7 2s, and then there would be 4 3s. I'm just going to move this out of the way. Oh, maybe I'm not. No. And then 4 3s, and then 3 4s. And in that list altogether, there will be 20 items. Okay, so to find the mean of this list of numbers, remember there's going to be 20 data points in the list, and you're going to have to do a little bit of calculating there. So 4 times 0 plus 2 times 1 plus 7 times 2, 4 times 3 plus 3 times 4. So it's 2 and 14, 16. 16 and 12 is 28. 28 and 12 is 40. 40 over 20. Actually, it's also 2. Okay, they don't always have to be the same, but they are in this case. They are in this case. So frequency distribution just shows you how the frequency of each data point is distributed. Here's a frequency table. It says my random variable here is the number of goals scored in a match, and then my frequency is the number of matches. So, you know, when I'm thinking, what's the question I'm asking? Well, I'm going along and I'm saying maybe how many goals were scored in your match today? And 3 people answered 1 goal was scored in my match, and 4 people answered 2 goals were scored, and 2 people answered 3 goals were scored. How many matches were played altogether? How many matches were played altogether? Well, if we think about this, and again, that's my capital sigma, that just means the total sum of. Well, in 3 matches there was 1 goal, in 4 matches there was 2 goals, in 2 matches there was 3 goals, 3 and 4 and 2. That's 9. There was 9 matches altogether. So there was 9 matches altogether here that were surveyed. In total, how many goals were scored? Well, we have to be a little bit careful here, because in 3 matches there was 1 goal scored. So if I was to write this out as a big list, I'd have 3 1s. And then in 4 matches there was 2 goals scored, so there'd be 4 2s in my list. And then in 2 matches there was 3 goals scored, so there'd be 2 3s in my list. So 3 and 8, that's 11, 11 and 6 is 17. Identify the mean number of goals scored per game. So to find the mean number of goals scored per game, I have to remember that this would be a list. If I was to write out my list when I collected my raw data, there was 3 1s in the list, there was 4 2s in the list, 2 3s in the list. So I'd count up all the total number of goals, 3 1s plus 4 2s plus 2 3s. Actually, I've done that in the first part there, in the previous part, 17. And then divide by the number of items in the list. We know there'll be 9 items in the list. 3 of them will be 1, 4 of them will be 2, and 2 of them will be 3s. So 17 divided by 9. Identify the median number of goals scored per game. Well, there are 9 entries in my list. The first 3 are 1s, the next 4 are 2s, and the next 2 are 3s. If there's 9 entries in the list, well, the 5th entry will be the median. Which will be the 5th entry? Well, the first 3 entries are all 1s. The next 4 are all 2s, which means the 5th entry is going to be a 2. Find the modal number of goals scored per game. Well, the modal number of goals scored per game is the number that occurs with the highest frequency. Well, 2 on my list will be 3 1s and 4 2s and 2 3s. So 2 will be the modal because it has the highest frequency. So 2 goals per game, that's the mode. If the mean of this distribution is 3, then find a value for x. Okay, well, to find the mean this distribution, so remember we say the mean, what do? We add up all the stuff. We add up all the stuff to get the total sum of the list and divide by the amount of values, the amount of data points in the list. So I've got to remember what this list would look like. Okay, well, x is my random variable, 1, 2, and then we don't know the third one. The 1 occurs 3 times in my list, the 4 occurs twice in my list. Sorry, the 1 occurs 3 times in my list, the 2 occurs 4 times in my list, and then this unknown number occurs twice. So I'm trying to find the value for x. Well, the mean, we know the mean is 3, that's given. And that's going to be the sum of all the things in the list. Well, in the list there are 3 ones. The 1 has a frequency of 3, so there's going to be 3 ones. And then there are going to be 4 2s. And then there's going to be 2, whatever the value of x is. So I'm going to write 2x divided by the total amount of things in the list. Remember the sum of all the things in the list, 3 and 4 is 7 and 2 is 9. There's 9 things in the list, so I'll be dividing by 9. Okay, simplifying there on the top, 3 1s are 3, 4 2s are 8, 3 and 8 are 11. So I get 11 plus 2x divided by 9. And now it's just a fairly standard linear equation. I'm going to multiply on both sides by 9, because that will cancel the division by 9 on the right. And 9 3s are 27. The 9s on the right cancel. I'm going to get 27 as 11 plus 2x. The next thing I'm doing to solve is I'm subtracting 11 from both sides. If equal quantities are subtracted from both sides of an equation, then the two sides remain equal. On the left, 27 subtract 11, well, that's 16. On the right, I'm going to get 2x. And then finally, to solve for x, I'm just dividing by 2 on both sides. Dividing by 2 on the left, 8, and on the right, x. So x is equal to 8. That's my final answer. What you've got to remember when you're looking at a frequency table and you're told anything about the mean, median, or mode is that it really represents a big list. If I was to draw this list out, we'd have 1, 1, 1. That's what it looks like, 3 1s. And then 4 2s, 2, 2, 2, 2. And then 2 x's, whatever they are. Well, we've just said x is 8, so we'd have a pair of 8s in there at the end. 8, 8. So that's what my list would look like. Okay. And if you add up all those numbers and divide by the amount of numbers, you'll find the mean is 3. Okay, let me look at one more example, and maybe we'll look at an example on grouped frequency distributions. So below is a data set showing the number of text messages sent from a phone over the last 30 days. So on day 1 there was 4 messages sent, on day 2 5, on day 3 1, on day 4 0, etc. I want to develop a grouped frequency distribution. Well, again, what we have always is we've got our values for our random variable, which in this case will be the number of text messages, and then the frequencies, the number of time that number will appear in the list. Okay, now notice we've got 0, we've got 1, we've 2, 3, 4, 5, 6, 7, 8, 9, 10's in there, 11 is in there, 12 is there, 14 is there. So rather than drawing out a big list, we can break this into little kind of groups. So depending on how wide you want to make the groups, maybe I'll make them 3 units wide. So go from 0 to, or 2 units wide, 0 to 2, but there'll be 3 entries in there, any 0s, any 1s or 2s. And then my next group would be, say, 3 to 5, and then my next group would be 6 to 8, and then my next group would be 9 to 11, and then my final group would be 12 to 14, something like that. And this is called a grouped frequency distribution. I'm just trying to make a bit of space here. Okay. So there's my groups. 0 to 2, 3 to 5, 6 to 8, 9 to 11. That's how those groups are looking. And I'm going to look at my frequencies. And my frequencies is 30 days, so my frequencies should all add up to 30. So in my first group, I'm looking at anything zeros or ones or twos. My first group, any zeros or ones or twos. 1, 2, 3, 4, 5, 6. And counting, you know, it sounds very easy, but it's very easy to make mistakes in here as well. 3 to 5, that's 3, 4, 5, 4, 5, 2, 3. Sorry, ignore that. I don't know. Just going to close that down. Okay, apologies. So start again. Any 3s or 4s or 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think there's 11 days where we sent between 3 and 5 texts. 6 to 8. I don't think it's 6s to 8. So any 6s or 7s or 8. 1, 2, 3, 4, 5, 6, 7. I'm getting 7 values in there. 9 to 11, so any 9s or 10s or 11s. So let's count those. There's 1, 2, 3, 4. I'm counting 4. And then any 12 to 14. 12s or 13s or 14s. 1, 2. I think that's it. 2. I'm going to double check my addition. 6 and 11 is 17. 17 and 7 is 24. 24 and 4 is 28. 28 and 2 is 30. I'm pretty confident that I've counted them all right because it's given me the right value there. 30. Frequency, the total sum of all the frequencies is 30. So that's what a grouped frequency looks like. And again, we look in maybe our next class about how to enter these frequency tables into your calculator. These can all be entered into your calculator. So frequency tables, practice, have a go at them, make sure you get used to them. Remember, you've got to understand what that means. There are 6 entries between 0 and 2, and ultimately a frequency table. Every frequency table in the world is just a big list that has been tidied up. Okay? So practice, practice, practice.